Let's go. Hello guys, welcome. Let's begin our live stream now. Oh, I believe the music is a little high now. Let's turn. Fine, it's good now. Let's see. Fine. Let's wait a little to start our live stream. Toho PNG. Oh, fuck you. I have not PNG here. This is a good one. This is really a good one. Let's put this. I'm gonna shut you. Yeah. So let's begin, guys. Into the last live stream, we have did a lot of things, and we have stopped it on I believe this one in this step. So if you not are familiar what we are doing the past live streams, we are trying to write a malware classificator. This is a classificator, is not a malware to determine if a malware is a malware, is a classifies this malware, and it's probably is a malware, and we can analyze and see in deeper what is the risk of this malware if you got it to in a way to get more confident level about the sample that we are gonna to analyze. So here is basically what I am doing. It's 50% of malware and 50% of trusted applications. The malwares are coming from our bazaar, and the trusted applications are coming from Aptoid. Okay, fine. And we are saving to 2 folders and extracting the features. The features in this case is the permission, but as you guys know, this is not the best way. It's just a way to get a feature for our application. This is not an end way to do this thing. It's just to do some example in this live stream, okay? So basically, we are extract all the features or all the manifest permissions of the HAPK, trusted, and more APKs. Previously, I know that there are some features that allow us to do this type of thing, but mainly this is not the best way, okay? If you can extract another features of the APK, it's fine. We are not gonna do this here in this live stream, okay? Our idea is just to write a simple classification for malware, for Android malware in this case, not a full classification that extract all the features from application, like, oh, let's see, for example, contents and providers and everything else, or maybe some heuristic more deeper in the application. We are not gonna do this thing here, just write a simple classifier. So with this knowledge, take in mind we are just extract permissions. This is not the best way, not the best way. Oh fuck, not the best way. But this works, right? This works. If you have watched the previous live stream, you will know that this works because we have some standard patterns that we can use. Where is my smartphone? Oh, bro, where did I put my smartphone? Fuck, I don't know, remember now. But is this way allow us to determine if a sample is a malware or not. And we are using the permissions for that. So with that, we have some x0 to xn or to preview or L, okay? Basically stat, and the x here is our permission set. We are working with a binary system. Oh fuck, no. Okay, this. A binary system, or just if we have this permission 1, otherwise 0. Okay, the same thing will apply to the I-axis. That is the preview that we are trying to do. If you see here, we have some interesting point. That is, you may ask me why you are working with binary data. This is a good way. It is because we can use this as input for a neural network or neural networks. So in this live stream, we will work with neural networks in 2 ways, or 2 different ways. The first one is using Keras, and the second one is YAML classifier from scikit-learn. But the final objective will be equals. We are gonna to get some score, accuracy score, like 85% or more. Okay, so of each sample that input on it, we have 85% to classify if it is a malware or not. Fine. So continuing the present live stream, we have did all these steps, like extracting the malware bazaar APKs and getting APKs from Aptoid as well, and we have a beginning getting all the permissions. As you remember into the previous live stream, we have extracted all the permissions from this guy. This guy have already done the job, so he created a text file with all Android permissions. You can extract it from Android documentation as well, but I will not do that, okay? I am not going to do this because this guy have already done this. And this is our model class. I will use this just to, oh, it is not, just to format our data set previously. So based on the data we have downloaded, we will format this into the sample class to create our data set. After that, we will sort the data on data set. So for example, when I say we are gonna set the data on data set, is basically if we have a sequential case like trusted, for example, safe and malware, and safe and malware. We will transform it into a randomization, like making our dataset be like this: safe, malware, malware, safe. So we will not create a standard to not create some type of vicious, I believe that the word, I don't know, but some type of bad action from our training, you know. If you are familiar with machine learning, you will know that we have some aspects that is, we separate, for example, here I have 100% of this, our data set is for training, okay? This is our full data set. So I take like two-thirds of this data set to training. So this is my training data, and this is like our test data, okay? Why this? Because we are gonna to not create a dependency from and false overfits for or machine learning algorithm. So basically, what is happening here is that if you imagine you are a student and your teacher passed to you a full set of questions that you will do a test, so maybe you can memorize all these things. The same thing can happen with our machine learning algorithm. So to avoid this, we get only a part of it. So this part is for training, and this part is for testing. Okay, just it. So after that, this step is done by the train class split. Okay, fine. And after that, we will input the algorithms. This is a neural network. If you are not familiar with neural network concepts, is basically we have our input layers that have our transformers or neurons here. We can have a lot of neurons, and these inputs are shared with all of these neurons, and after processing each of these neurons multiple times based on the epoch. If you do not familiar with epoch is the number of the input layer will be interacted with your neurons here, and these can create a lot of neurons and finishing to only with a unique neuron that is called sigmoid. You know, this is sigmoid. This is the output layer, but into our example here, we will have a previous layer that will constrain all of the neurons and pass this into a sigmoid algorithm to generate our output. Okay, I hope this can be clear for you guys, and this is what we are gonna do into this step. Okay, with MP classifier that is from scikit-learn and TensorFlow Keras. Fine. And okay, after training, we want to make sure that our algorithm or model is really working, right? So how we can do this thing? For MP classifier, I will do accuracy score, a k-fold validations. I will explain each one of this, but we do a k-fold classification and a classification report to see how the displayment of our training data is on our report, you know. And then for TensorFlow Keras, I will do the same thing, but for classification report and plotting the loss and valid accuracy from our history. Keras create a history that records all the events from our learning process. Like, let's create some graphic here, blah, blah, some plot. So maybe we have our validation into a normal and correct machine learning algorithm, or accuracy needs to, let's take another color here. Let's take a red and get a small size. So for accuracy, our accuracy needs to grow, right? And our loss needs to grow. So our loss starts generally from here and it needs to down. So basically this thing will plot our loss graphic and validation accuracy and valid accuracy, because we have two types of accuracy here. We have the accuracy itself and we have the loss itself. So if you want to, let's write something here like hacky. So fucking blue is red. So for red, we have our accuracy, right? And for the blue one, fuck. So dumb, sorry guys. So for into red, we have our accuracy, right? And now for our loss is the blue, okay? Blue is our loss. So basically, when we plot this graphic, we are gonna see black. Right. We are gonna see if our graphic is growing or accuracies, or if our input in the training test and the fit and training model is increasing, and or blue if our loss is decreasing. If this not happen, probably our model are wrong. And after that, we will also generate a classification report, okay? So this is the mechanisms that we are gonna try to go into this live stream. After that, if we really want, if everything perform well, right guys, everything perform well, and we want to make sure and test our accuracy model, we are expecting to have something like 87% of accuracy. This is our goal, okay? This is really great. Any value, or sorry, any model that have more than 80% of accuracy, basically this is a really good model, right? And this is our goal here in this live stream. It is possible. We are not gonna reach probably something like 95% of accuracy, because we are using only one feature in this case, right? That is our feature extract permissions, or permissions from our manifesto, right? So this is our goal. If it is be matched and we be able to get 87% of accuracy, we will test with real samples. So basically, when we say we test with real samples, we will bring malwares, real malwares from a repository. I have a repository here that has all the malwares, Android malwares from the 2019 malware collection. So every family that has been developed and into this year will be onto this repository, and we will test if we are able to detect and classify these malwares, right? So with test, we will do this test with all malware families from 2019, right? If you are wondering why you are using 2019 malwares, is because we can do something more accuracy using VirusTotal API, but we do not have access to VirusTotal API, okay? And this is not a good idea to do, because this is a really simple model. And VirusTotal is not good to do this for now, right? So after that, we will save this model. Probably we use something like Picker. If you are familiar with Picker, we are gonna use this. And for TensorFlow, we can just export using the export function. And after that, if everything go well, or tests be well as well, because remember, we need to be able to classify with 8% of accuracy. If we test with real samples, and for example, none of the samples get classified, so something are wrong with your model, right? We hope not, but this is a possibility to have. So after everything go well, we can create a simple tool to scanning APKs in live stream as well. Fine? So these are the plans we are gonna do. I hope this go well, right? Let's take something here. So let's do it. Guys, for our model sample, I have thinking into a better way for us to store this type of data. For example, now we are just storing the permissions and the verdict of each sample we are going to analyze, right? But I need as well to store another field in our dataset. We will not use this for training, but I will store our SHA-206, right? And let's do it, 106, and create a getter for it as well. So I am gonna do this. You will to be able to store the hashes of the samples that we are training our data set to have a better control, right? So fine, this is the routine. Before this, I have my Marbazar API, so is because of this that I am hiding it, okay? And if you want to see this part of the notebook, Jupyter Notebook, you can just see the links that I will share with you guys. So let's go. This is the routine to download from our bazaar. We are stopped it, and this for download from Aptoid, right? And this to get all the permissions from Android for I be able to use it. So let's create our model class. Fine. Now let's go to the next step. The next step, guys, is to maybe get all of your or samples, and let's first run and get some samples for testing. Let's run to our bazaar. Let's hope that everything goes fine with this. Oh, this will take some time. Guys, I have already to make more faster or live stream. I have already made a dataset, but it's not time for now, okay? Before using this, we are going to download the sample itself. But there's something wrong here. Let's see what's going on. It's not downloading. Oh, it is downloading. Fine. Okay, we have a sufficient samples for now. We are just developing for now. Let's take some samples from Aptoid as well. Let's see the Discord. Fine. Probably we have enough samples to train. Let's download this Discord one. Fine. Fine, perfectly. Let's download this one. Fine. And fine. So now we have the folders here. We have the trusted. We have the malware case. That is the two folders we have planned to create and store the samples. I have the model class here, and before this I am going to code something to get all the files from our malware APKs and trusted folders, right? To be able to create a list with all the samples for processing, right? The music is in a good level, guys, or you want to stop the music or change the music, be free to say something. So let's begin. Let's first get all the let's get all the trust applications or malware applications. Let's first begin getting all the malware applications, right? So we will use OS for the paths. We are gonna use pathlib for the paths. Import path, fine. And let's begin. So I will create a def here, and this def will return or list of malwares APKs. Okay, so just malwares. Let's do it. Get malware APKs path. Paths or paths. Paths is awful. Paths is better. And basically, what it is gonna do is first get our base dir directory. Our base directory, guys, will be our malware APK, so we can just instantiate a class path, pass, so that is one, and pass our malware's APKs to it. After that, we can create APK paths, and the Google are really doing the job for us. Should I accept it, guys, or not? I will not accept this, okay? Because Google is wrong. So let's create APK paths here. Let's see the chat. Fine. Only 2 guys. No problems. I'm looking for this. Oh, let's put a cool music here. Did you guys remember this music? This is a good music. This is from Key Jane music. There are another one music from our group that is from Digital Insanity. If you guys remember it, it is this one. Digital. So let's code while we listing this music. It's better, guys. If not, fuck. Return empty. No, it's wrong. This one. This is a subdir, fine. But there's something I want to check. We have to get the APK file that is on the subdirectory and concatenate with subdir name.apk. Check if it is the file and append it to the list. Fine. Let's run it and see if we got. Oh, fine, we got it. We got it? No, we not got it because this is a POSIX path, but we can use the str type constructor to remove the POSIX path, okay? Fine, now we got it. But it's not this we are gonna looking, guys. We are just taking this as a malware paths, is bad. And let's print to create some metric here, like malware paths. We have lan malware paths, just to have a count of how much samples we have. We have a 7 malware samples. Fine. Let's continue. Oh, happy nation. So after this, after this, let's get the trusted APK. So let's get all the applications that is trusted and create and do the same thing. Create a list with all applications, right? Let's go fast with this. Get trusted APKs. As well, if you have a base there that is trusted, Google got it. Perfect. Fine, we can use this. No, wait, let me think. How is the level of this? Well, we have a not subdirectory file. We have a device directory, so maybe we can create APKs into our base dir iterating after file, check if it's a file, and a pen. Fine, is it. Probably we have only APKs here. I hope we have only APKs here. Otherwise, we will have a problem. So I will start this owl maybe and use a prefix like owl. So fuck. Trusted. That's fine. So what? Fuck. Dumb. Trusted. Fuck man, no. Fuck, let's take this. This here. Land. All trusted paths. Fine. So running, we have 4 trusted APKs. Bro, let's make this better. Trusted mal. Fine, it's better, nah? Right, guys? So now, after doing this, we have the counting of the samples that we have in each folder and the paths of each sample. For example, of each APK files here and each APK files in each subdirectories here, we have all the directories to process, right? So, let's process. So guys, for process, if you remember into our last live stream, you have never watched it. Sorry, you have never listening the Happy Nation music. No way, bro. True it. This is a classic. A really classic music. After that, we will listing as well deeper anime openings and J-pop playlist of mine, you know. Probably you guys will enjoy that. I hope you guys enjoy that. Now I will put some song from Azrael. If you never watch Azrael, this song, guys, came from an anime called 11 Nights, right? It's a really good anime. Let me take this for you guys see. Let's take my tab. 11 Nights. This one is really good. Really good. I recommend for you guys. This is from 2009 anime, and the soundtrack is so good. So the music that I are listing now came from this anime, right? And Crunchyroll has this anime, so you can watch it from this, okay? I really recommend. It's really good. So continuing, we are gonna to do the parsing of the features from our APKs file. But before doing that, you guys can remember, starting to the previous live stream, I've told you guys that we are gonna use Android, right? This is not bad, right? It's really good and cool. But using Android, there are some details that Android. Yeah, Android. I'm not crazy. What the fuck? For a minute, I have thinking that I'm crazy. But basically, we are gonna use Android. But Android sucks, guys. Sucks a lot. Why it sucks? Because they use a bad logging system. Bad log system. Moby, are you in the live stream? So probably you agree with me. Bro, this logging system is so bad. So we are gonna turn off the logging system from Underguard to process more fast, okay? To not generate so much verbose for our is this one logger. They use the library logger. This is so bad, so bad. The library is incredible, Underguard is incredible, but the logging system sucks a lot. So we are gonna to deactivate this, okay? So first of all, let's take my hash lib because I will generate the SHA-206 and let's import Androguard. I have a really take Androguard, okay? So we are going to take the model core and we'll take the APK file, right? And import APK itself, APK class. Before deactivating the logo class, I will show you guys what I'm talking about because it really sucks. Let me show you guys how much this sucks. Let's take some. No, I will not take an malware because this is too much bad. It will for sure crash my tab. So if we will run, did you see this? This is. Let's stop. Oh, it's crashing. You see? It's crashing. Fuck. Guys, I will stop the live stream. I told you guys, this really sucks a lot. Fine, I have stopped it. Let's return to live stream. So, this is bad, right? If you see, this is the verbose output. This sucks a lot. This crash. You cannot use this in a good way. The Google really sucked a lot as well. Do you see this? Fuck. So this is bad. Why this guy uses this log system? It's really so bad. So let's turn off this logging system. It's not hard, guys. To turn off logger, it's simple as going from logger and importing the class logger, and then calling logger dot remove. Fine. Only this. Remove this all these things. Did you see? We are really processing it. Did you guys show how bad is the login system of these guys? The library is incredible. It's so useful, but their log system sucks a lot. So much verbose. This is not necessary and create a lot of bad stuffs that just crash our Jupyter notebook. So fixing this now, let's load this line and I will create some algorithm to calculate the SHA-206 from our APK file, right? So let's do it. Calculate. Google. No. From file. Fine. We take a file as a parameter, and then we open this file, writing the binary data. Fuck, this one is better. SF. Now we instantiate our SHA-206, and this is bad. Why are you doing this? No, bro. Oh, so bad. we can just read all the buffer directly. So much better. I don't know what these guys are. Oh no, Google, what the fuck, man? Let's see the chat. So I will put now another soundtrack from 11 Eyes. I hope you guys like it and enjoy watching the live stream with the sounds. It's really good, guys. I hope you enjoy it. So fine. Let's drink wine. Now we have updated our hash. Let's calculate the digest of this hash. So I'll call this SHA-206 hash as and take our object that I have instantiated here and get X digest. As well, we'll do the same thing to get the string. So, but first of all, sorry guys, I will just oh yeah, return str of our hash is a digest, but oh, I don't remember. Did you guys prefer it uppercase or lowercase? Lowercase is the standard. The major IOCs list use the lower, so you use the lower. Okay, so if you do not agree with this, just use upper as authorized of me, and return empty if this not. If you not be able to calculate. This case will not happen, okay, but it's just here to complete the code itself. You are not closing the file. Yeah, I'm not closing the file. Fuck, I'm not closing the stream. You're right. But yeah, fuck. No, I'm not closing this. It's not necessary. Python VM will close it for us. There's no problem. So, oh my goodness. So let's track the features from our APK. So, extracting the features, right? It's not hard, it's just trust in, wow. Oh, he got it for a try catch. This is so great. If it is crash, there's nothing we can do. We want only to capture this exception, right? And print it. Maybe. What? Where is my cursor? Oh, it's here. Underguard can throw some exceptions when he was not able to parse, right, guys? Oh, this is str. It's because of this zone. And when he no, there's not necessary to cast with this. Fuck. Underguard can throw some exceptions, so we are gonna to avoid this. Oh, let me save this. I will share this with you guys to explain what is the neural net after this. If you want to, oh Google, I hate this. This is a PNG file or this is a suspect PNG file? What the fuck, man? So maybe let's take this open here for. So we are referring as the neural nets. Take this in your mind. What is a neural net? If you want to remember it, we have our input layer that there's our features that interact with each neuron. We have more neurons or mini neurons. It depends on the configuration of your network. We have a sigmoid here to centralize all the neurons result and generate some output, right? This is a wrong representation because this is wrong. This is not a good way to represent how a neural net works, but for our example, it feels good. So, I am lazy to not create some good way for you guys too. But this is not. Oh fuck yeah, fuck. I will not do this. I will think to do this in the next live stream maybe. So, why? Yeah, this is correct. Really correct. But I will not do this. Google sucks. Wow, he inferred that we have a list? No, he not inferred it. But guys, I will have a global list here that will store the samples. This, I will call it a sample list. So then we'll create it a sample list. Maybe it's a good way. Like this. And then we'll store. Fuck. No way, man. I typed so fast. Instantiate the class sample. And then get the permissions. If you guys are wondering, look how many features you can use for training. But we are lazy. We are gonna use only the permissions. So you guys can make this better, probably. Do it for me, right? And I will assign a label for this. This label, guys, will be or verdict. In this case, is S, so safe, right? And then after that, I will get the. I will calculate. Sorry, the hash for our file and store the string into the shade 206 as well, right? So is it after this, after running everything here, we'll have a list with a lot of instances of sample class with safe malwares permissions there, right? Let's run. No, fuck, it's this one. Why is it not running? Oh no, fuck, run. Yeah, run now, run. Yeah. Not a process. Your name sample is not defined. Sample is not defined. Oh, maybe Google has restored everything. Oh fuck, this is bad. Let's run this as well. Bro, Google sucks, right? Running now. Yeah, now we have the instances of our classes. Fine. Let's do the same thing as we said here to create our populate our dataset. We are in this step. Let's do the same thing for our malware case. But first, let me drink water. Let me see the chat. Fine. So let's do the same thing for malwares. It's exactly the same algorithm, but just change the thing here. That, yeah. Looking to the side, I can create some depth for it, right, guys? Sorry. Sorry. No. What I'm doing, bro? Fuck. Let's do it. So let's do it. Struct features. Google got it, but Google is wrong, as expected. Google AI is good, but sucks in sometimes. Let's have the paths that we wanna parse, and the verdict. Bro, why are we calling verdict is verdict, bro? No. I have wrong with this. No, this is verdict. Why? Where did this come from? Where did verdict come from, bro? No way. No, bro, this is crazy. What? Oh fuck, I'm doing some bullshit here. But where did this come from? I'm just coding here, and I'm typing right. What the fuck? Okay, so I will not think about this. Fine, we can create some depth and it will be so much better, right? So much better. And we want just to pass like this, or trusted samples, safe, and or malware samples, all malware paths as malwares, right? Let's run. First, let me drink water. The music has stopped. Okay, I will continue the music. Let me think what we can put this. Did you guys like Data Live? Did you guys know what Data Live is? I will put some OST from Data Live. It's really good anime. I recommend it as well. But I have a complete of all the openings of Data Live, but I cannot find it now. All openings. Where is it come from? Oh, here. This is the first opening. This thing, guys, comes from an anime called Data Live. This is my favorite anime of all the time, right? So good. I really recommend for you guys. Watch this anime. Watch 11 Lies. So good recommendations for you guys. So crazy and good animes. Watch it. I really recommend. So, continuing. We have the lists and the classes into our list. This is our... let's rename this as our sample list to create some type of pattern here. And fine. Let's now get everything that is on our sample list. We have instances of our class sample, right? So then, what we want to do now is to randomize our samples. As I told you guys here, we have extracted the features. We have not created a dataset yet. We will create it now. But first, we want to sort all data on the dataset. So basically, if you see here, we have some X standard. We know that we have 7 malware samples and 4 trusted. So I know that these first 4 values are trusted, and these ones are malware. So to not create certain dependency of our algorithm, or classification algorithm, or machine learning algorithm, I will randomize the order of this, right? Let me show you guys some better example of this. Let's create some for loop sample in samples. Fine. Let's create some sample dot get verdict. Okay. Let's get the verdict and print each verdict. So you see, this is what is happening. This is bad. We cannot do this. Fine. We cannot do this for training. We are not gonna train now, but we cannot do this. So, to avoid this type of thing, we can use random. Yeah, we can use random for this. So, using Python random, like this, we have a method called shuffle that do really what we want, that is randomize the data, like this. Did you see? This is now randomized. If you run this, it will be different all the time. This will not create some dependency for our machine learning algorithm. We will make sure that he will not be able to guess what you're... Oh, yeah, he will guess, but he will not be able to memorize or input samples. So, thinking the example of the student, we have a student. So maybe we have a student here. Let's drown the fucking student here. He's from Gen Z student. He is trying to learn something that her teacher that his teacher is trying to teach. Like, the teacher make the mistake that put everything in question from their test into a paper, right? And share this for this student stud these questions. But the teacher have applied a test for these Gen Z guys and took these questions. So the Gen Z guy is smarter enough to be lazy, and he do something really creative here, that is memorize all the tests. So if you see here, has this guy learned something, or he has just memorized everything question and everything answer for the test that his teacher has passed on the for study? He has memorized, he has not learned. The same thing happens if you study in Brazil, when you try to memorize all the stuffs before some test into your school. You are not learning. I'm not going to merit that the Brazilian study is good or not. He's bad, really bad, but it's not the case now. I am telling you guys that this guy has memorized the questions. He has not learned. He just memorized. He knows that the answer is this. But there's no logic here, right? He has not think of this. He has memorized. So let's test another scenario. Into this test, he got accuracy, or the results. He got 100% score. But he memorized this. He memorized it. You got it? So, this another teacher from the same school, from this Gen Z guy, have done a similar thing. He has created a list for this guy's stud, but he has not shared the full list. He have only shared this part of the list here, right? So the student have studied these things, but the teacher, the second teacher, was smart enough to formalize the test questions based on the things that he has not shared to the Gen Z guy. So did you guys can guess what's happened here? This was a disaster. The Gen Z guys has make a 10%, a 20% accuracy. So look at this. Into a scenario, he has just memorized the things. Into another scenario, he has studied these things, or memorized these things as well. If the same Gen Z student, if he is not a Gen Z, probably he has learned it, right? And then he has took this test and make 20% score. So he has not really learned, right? So the same concept happens in machine learning. And this is called overfit, guys. This is called overfit. Did you guess this? This be clear in your mind? This is overfit. Remember, when we talk about overfit, remember about the Gen Z guy. He is not smart enough to study. He memorized everything. But he memorized everything because because of his teacher has not make him think of what he has learned, but memorize the things. It's because of this he make 100% score. But in another case, he has really tried to make the student learn. But the student has not learned this into this example because he is a Gen Z and he is not smart enough. So in this case, the computer is more smart than a Gen Z guys into this aspect, because he will really study this thing if you are smart enough to create the correct thing to train this guy, right? We have a lot of models and we can just make this guy stud as well. So is this that really happen, okay? In your computer when a machine learning algorithm is gonna be trained. And this, just to this, just to this, just to this, and just to this. This is the neurons. This is our neurons. This is the input layer. Our features. This is the sigmoid. This one is the sigmoid. And this one is the result that's coming from sigmoid. So this is the brain of our not more Gen Z student, but different type of Gen Z, right? So he is the type smarter of Gen Z. And this is the brain. So he has studied a lot. He has taken about it. He's tried to memorize. He's tried to solve these problems without thinking without seeing the answer and stuff like that. He really learned it. So the score be too much greater. He took 80%, right? So this is a really small example of what overfit is. So going back here, let's now do the things. Now you guys probably have learned it or not. I don't know. I hope yes. You guys have learned how this works, right? And now is the time to get the features to finally create our dataset. Okay. I will run this to create a newer dataset from scratch. Fine. And then I will work with our permissions, and I will put in our permissions a field for very dict. And also we'll put one for SHA-206. So basically, here. Uh, I will have our X inputs layer or features here. I will have a features here. I will have my output, that is my verdict, and we will have a field that we will not use it for training, just to store the hashes. That will be SHA-200 section, right, guys? Then let's start parsing these things. If you're wondering what we have inside permissions, let me show you guys. I have these things. So I have all the features, all the permissions that is possible to have into our dataset columns. And then I will append the verdict and SHA-206. I will create here as well some column that will be the column of our dataset. And I will, so sleepy. I will recreate this. Have the columns and permissions. Let me see the chat. Let me drink water. Fine. Let's continue our concepts. So, now guys, I will do something called burn a match. Basically, I will implement an algorithm that will take the sample class predicts permissions and the permissions, and then we will match 1 by 0 to check if it is on the permission and set it to 1 if it is, okay? So let's do this. I will create some called data here, and the data will be our dataset data, so we'll call it dataset data because it's better. And then I will take each sample in sample list, all sample list that is here. Where is it? I have a sample list. What the fuck? Oh yeah, here. Fuck. I'm dumb. So I have all sample list here, and I will create a line into the sample list, and this line will be the size of size. Oh my goodness. I program in Python, but C++ never always stay with me. Did you see that I have a typed size of? No way, man. No way. So let's create that based on the length of our permissions. And then I have a list with all the... What? No. Looks like Google have learned for a range of this. No, Google is wrong. No, Google is not wrong. Google is... No. Guys. No, Google is really wrong. This will not work. But I will create some I equals 1. And then... fuck. And then I will go throw off this permission. So I in all permissions like this, and I'll create another one to throw if each permissions in sample permissions. And he got it. But Google is a little wrong because what we are looking here is to take the permission here and to make sure that everything will be smoothly and most correct possible, I will convert and force converting it to lower, okay? To match correctly. And I will try to match it with our lower case here as well. If it is, we just set our line to 1, that is true. So we have this permission in the application. And then I will increment my I with 1, and is that. Now I will go to my line, but I will go to the end of this line, guys. And it will be len of my all permissions. I will subtract 2 because I want to access the verdict, right? And the permission. Google got it correctly. Thank you, Google. And fine, guys. Now we have a pre-dataset. We have a process or dataset, but what? What? Bro, what the hell have I done? Let me read this code. Oh. Oh no. This needs to be a controller. Create J. J is bad. Increment J to access the index of it. And what? Let me check what's happening here wrong and is wrong. Oh, this is wrong. I am incrementing with each sample to 0 broke. Fine. If you see, this is a malware, this is the hash, and the feature is set incorrect, you see? Is everything correct? But I was dumb here. So okay, we have the data set here. Now I will create some data frame from pandas, okay? Let's run this. Fine. Let's create a data set, so import pandas as pd. Data frame is equal to or pd the data frame. He already got it. Data set and columns, that is our column here. And I will not save it. But you can save it, guys, using this to CSV, okay? This is a good way to not need to download everything again. Running it. Okay, now we have our data frame with the samples and if he is trusted or not, okay? Fine. So, is it, guys? Now we have our data set. But I have already done this. I will show something more interesting to you now. Okay, now we have our dataset, our full dataset. It's time to get samples, right? So basically, we want to download. Oh, my API has leaked. I will revoke this API. Anyone will try to to do bad things with my API. Okay, it's leaked now, so you can see this is my API. There's nothing here. You can just use it. I will reset it. No problem. But basically, now it's time to get the much possible quantity of samples you can and create a really big data set with a lot of samples, the most lot you can, okay? I have a read done this. First, let me um, change the music. Drink water is important. I have already done this, and this is the guy. I have downloaded the guy. 875 samples. It's a lot, right? And I will share it with you guys. Here, I have my verdict and my SHA-206. And the permissions features. Do you see this? We have 875 samples here with the verdict and each features that we will use as input for our training data, right? So now, I will use this one for training, right? And you can get this same dataset. If you really do not want to go here, download samples, spend a lot of time getting samples. I took, guys, 4 hours to get all the samples. It's crazy, right? It's crazy. But it's a hard job that you really want to do to create a consistent machine learning algorithm, right? So I really have done this. Fuck, what's happening? Fuck. So let's import my already trained dataset, okay? This music that you guys are listening is from 11 Eyes as well, okay? Really good. I'm thinking to put Stax as well. Stax is another really good singer, but his style is from Tuhu. If you really want and like Tuhu style, you really want to try Classic Records, bro. So good. So this music now is from Classic Records. Really good. So now we have our sample are really into this data set. We have created the data set here. Now let's begin the fun. Let's training this data set. So for them, I have already imported pandas, but I will import it again. Pandas SPD to make sure. And is that I will get our dataset and get it. So I will get the dataset here and read this dataset. Did you see? I have some broken columns in this dataset. It's because of index. When we save this dataset here in disk using df.2csv, this will create the index. I can control this index, but I was dumb. In the time I have created this to training, I have not hide the number of the lines, right? So I will remove this now. It's not a problem, it's not difficult, it's really easy to remove. So now we got our samples, right? We got our dataset. Let's get our X. First of all, I will drop here I will drop the column. The column, this we want it to be specified is a column like this. Is you name it 0. This will just remove this column that we are not using. Columns, because it's a tuple, right? Fine. No, what? Not finding access. Name it. Why not? Oh, is you name it. Now it will be fine. And then I will drop out as well. So this is X. Drop the verdict. And I will pass the X is equal to 1. X is equal to 1, guys. Refer to column, okay? It's basically, I can do the same thing here, but I can just, if I am dropping only one column, I can do this thing. And for I will get df data frame and the column verdict, right? Guys, another point I wanted to teach you is machine learning algorithms are not good with letters. You can just, it's better and recommended to fix this data for, so I will fix removing s by 1 and m by 0, right? No, wait. I will remove m by 1 and s by 0. It's not so hard to do this. It's easy as doing a replace with or malware where we have the field malware. We will put it as 1, so it is a malware, and s is a trusted, is 0. And I will print all the data here. Oh, this is wrong because there's a tuple as well. Fine. Did you see? I have removed everything. Let's print our X here. Did you see, guys? Oh, we still have the hash, you see? This is my mistake. So to fix this, guys, is just dropping SHA-206, right? And after generating it again, we have no more SHA-206 row. And we have just binary data, or 1 byte or 0, but we can use the field unique to have which values we have. So we have only 1 and 0, right? Fine. After that, we can really split or test in training data. Let me drink water. As I told you guys, this is not hard. It's really easy to do, but needs to be done in a correct way to not overfit the data, right? So remember about the student that the GZ student that we have talked about. To avoid doing this type of thing, we will do the same thing that the second teacher has done, separating the data, a specific part of this data for the student test, right? So we will do the same thing. Into scikit-learn, we have a good method to do this for us that is called train test split, but this needs to be configured correctly, right? So the first one is xtrain. The second one is test. Another one is train. Another one is test. And then we call train test split. And we pass as a parameter or x or features, input features, and output, right? But there are some things that we want to configure here. First, let's put some music. For we be able, oh, you put some music that is called the phantom shit is really good as well, right? So to avoid, so I have demonstrated for you guys how overfit works. Usually it's normal and the standard to get something like 20% of this data to training, right? Sorry, to to test, and the rest one to train. So is this I am gonna use. Remember about, but stay with this concept in your mind about the Gen Z student. He's dumb, he wants to memorize everything. So your machine learning is basically as well a Gen Z student, he's dumb, but we want to force he learn, right? What we force this guy learn? Splitting the test, separating some part, whoa, my music stopped. Some part to test and some part to train, right? And forcing their brain, in this case their neurons, to learn what we are inputting for him, right? If he learns successfully, he can get some good performance. Otherwise, he will get, if he memorize the things, a wrong performance. So let's do it, guys. To split our train test set, we can use the test size and put like 2/3, that's 20% of this train data set. And another important parameter here. Okay. Now talking about our sort data dataset, we have already done this using shuffle, but here I have done this using shuffle. But into train test split, we can create some random state. There are two common random states that the people really use in machine learning. The first one is for 2. Yeah, it's the same as the response for universe and everything else. And the first one, and that I really prefer, because we have a really randomized the train data set, is the 1, okay? So I will set this state to random state, so I will not randomize the data of training. And this is it. So now we have split the test, I have split the train data. It's time for training, right? If you remember, I've told you guys that I will train it in a dual way. The first one, both of these ones are neural networks. So I will use MP classifier and I will use TensorFlow and the model carries, right? Remember, before explaining how neural net works and showing how to configure one, I will show you guys how explain a little the concept of how these images and neurons and layers and everything else works. We have an input layer. This input layer is basically our feature, so our X. If you remember our X are the permissions itself that we have here, right? And this will just train based on the neurons. The neurons, the most common neuron that is shared by MP classifier and TensorFlow uses an algorithm, a mathematical algorithm that is called ReLU, right? ReLU. So each neuron uses ReLU in this case, in our training data set that we will train now. And this finish putting everything together into only one neuron that is called, that uses the algorithm and the mathematical formula of sigmoid, right? This is the basic of the calculus that is really cool to have some concept and how this can be used in this type of classification, okay? But I'm trying to go really deeper of it, not too deeper of it, for be able to understand how it really works, right? So let me drink water and let's continue. So this is the basic. Our input layers, for example, our features, will be training for each neuron. So I have a feature here that is called, okay, this one, access all downloads. So he will pass this access all downloads to this neuron, he will pass this to this neuron, he will pass this to this neuron, he will pass this to this neuron and this neuron, right? The same will happen with other layers as well, of other features. Then, after running ReLU mathematical algorithm, this will do the same thing here to the next neuron, the next neuron, the next neuron. So, this will repeat based on something called epoch, guys. If you are not familiar, epoch, guys, is basically the number of iterations we are gonna use here, okay? So the maximum iteration here is based in the determining by the epoch. Fine. That is the number of passes that our features will pass through our neurons. This will concentrate into only one neuron. This is an example that runs a mathematical algorithm called sigmoid. And then generate a float point value going to 0 to 1. Okay? And this is the result of our sigmoid that will determine if it is a malware or not a malware. Fine? So, fine. Let's now... Fuck. Let me delete this. So let's now train. I will first use sklearn MLP classifier. Okay. And I will do all these things. I will calculate the accuracy score. I will calculate k-fold validation and as well classification report. Okay. After this, I will go to Keras. But first of all, let's focus on sklearn MP classifier. So let's do it. Let's import from sklearn neural network MLP classifier. And to import our accuracy score, we can import this from accuracy score. Thank you, Google. And to our model selection, we can get the classification report from metrics as well, and we can import another one that is from sklearn as well. That is our cross value score. Okay, I will not use the confusion metrics here. I will use k-fold. K-fold. Okay, that is better for me. I like it, using it. That is started here into this. Oh, neutral, no. Neural. That is started into this class. So this method is run the k-fold validation. Okay, let me show you guys what is k-fold validation. Sorry. This was recommended by a friend called Buzzer. He's not in this live stream now, probably, but he has recommended this for me, right? So this is the k-fold. Basically, this algorithm will split in or training or dataset of our entire dataset, and they run the algorithm calculating the score of it to check for false positives, right? So let's do it. MLP classifier, and let's configure. First of all, we have the hidden layers. If you are wondering, guys, what is hidden layers? Hidden layers defines the architecture of our neural net. So basically, how much, how to say commands? Oh, let me think. How much layers or neurons will have, right? So how much neurons and layers will have? I really have tested a lot and create a really variable size of layers and tested which one will be better for our data set. And I have going to the conclusion that the best hiding layer will be 15 neurons by 4 layers, right? And the second one parameter, guys, is the, let me open the documentation. I believe it's better because this really concept is really a mess to explain. So let's take it here. So now we are gonna determine the activation function to our hiding layers, right? No, sorry. No, this is not used. Here default is relu. Please stay with your relu because relu is really a cool linear function to run based on this dataset, right? But the solver, you use the advanced solver, right? This is a great algorithm based on the gradient, and probably will be the best choice here for now. I will do this. I will use this add-on as our solver. The second one is the batch size, guys. The batch size is based on the weight of the is based on the the weight of the memory consumption, the memory consumed, right? And the good standard that I have chosen for our algorithm dataset and for our big dataset, it will do a really good actualization frequency, and I have going to a conclusion that this will be 13, right? So our batch size will be 13. And the learning rate is the initial learning rate. For example, if we pass it a small number, or graduate rate will decrease, and this will be not good because our values can diverge a lot. So how much bigger this number, how much fast will be our training, but how much lower this value, much slow it will be, but at the same time it will be more precision, right? The accuracy will be more good, the training will be more, we will have more caution, right? So the learning rate that I use is really, learning rate is 0.004, right? And another parameter that I'm going to use will be the max iteration. So guys, the max iteration is the number of iterations that are epochs that our features will do on the neurons, right? By standard, I like to use 200 iterations by each feature, right? And if you want to use a shuffle will be shuffle the sample or randomize the sample on each iteration. So if you iteration this feature, this will shuffle or will change the randomic position of this one and train again, okay, into the neurons. So this is recommended and this is good to do, right? So you do this one, it's true. And the last one is also the random state. So I will not randomize the order of this training dataset, only shuffle it, but not randomize to to fit or match with or test interest split dataset to not randomize too much, right? So this is the configuration of my neurons net that I have done. And now I will try to predict the data. Sorry, I will try to train the data. So to train is just fit. We call the method fit and train all the data on the X train and I train, right? And now let me drink some water. Before let's put some music here. Before we continue, let's put some music. I'm really tired, guys. I haven't worked today, so fuck. I will put some Toho music. If you guys like it, I hope yes. It's great. Cool. So let's calculate the accuracy of our training. To calculate our accuracy, guys, is basic. I will use the classification report based on our test and predicting the X test that we have separated here to training and testing. Remember again about the Gen Z guy. Gen Z guy are not smart. He's dumb. So our machine learning algorithm also is dumb. He's from Gen Z. He don't know. He prefer to go to the most easy way. If you will formulate a specific list, he will not learn it. He will memorize it. So now is the time to apply this test. We have taken a good way to do this, like is splitting the test and the training dataset to see if your Gen Z guy have really learned it, okay? So let's do it. I will do it through the predict. So I will try to predict based on the test. This is the test that is features that I am inputting in the model, this one. It will pass through our neurons to sigmoid and generating our result, right? And the classification report generates a report of how was the performance of this, okay? And as well, guys, I will calculate the accuracy score. Accuracy score will just print to us the score of our model. So, how percent he is right, like this. Oh, I'm doing something wrong. What's wrong? It's not coded. Oh yeah, it's not coded. Multiply 100%. No. Oh fuck. Okay, I have to fix this. It's good, no problem. But this is percent. And let me check what is there. We got it. Oh fuck, it's not learning hate, it's learning hate in it. Okay. Fine, it's training now. Let's see. What? Oh fuck, yeah. My bad. So, let's see how was the performance of our model. 90%. Okay. Let's think. Did you guys think that this is a overfit case or not? Can you guess? This is overfit or not? Remember, what we have told about overfitting, about GNZ guys, this is not an overfit case, guys. This is really our score. So, based on the training dataset, on the test dataset, he has make 90% of this training dataset correct, right? So he has done 90% of this correct. So our accuracy is 90%. If you guys remember, I have told you guys to make to make this more fast. I have collected samples. I've collected 175 samples based on the algorithm that I have showed to you here. So based on this dataset that we have a constructor from scratch, we got 90% or 89% score rate. But is this our real score? Now it's time to apply something called K-fold, right? K-fold, guys, is a... Where is my mouse? What the fuck? Oh no. Bro, Firefox has crashed, guys. Let me fix this. Sorry, guys. My browser has crashed. Fuck. I'm trying to restart my browser. 1 minute. Oh, fuck. This is bad. This is not the time to crash. Why you crash it? Fuck. So bad. Force kit. Fine. Okay, let's reopen my browser and see what's happening. Sorry, guys. These mistakes happens. It's bad, but happens. Damn. Let's put some music as well here for you guys. Wait. Put some Toho music, more calm. Fine. So come back here, guys. I will run. Oh, is I not need to run? So come back. I will see that we have 9% score, but now it's time to make sure that this score is correct or not. To do this, I will apply and use an algorithm called K-fold validation, right? Or call it the cross validation. Let's do it. To return a top of a list of scores. Let's take this. I'll pass the MP, X, CV, and the counter of cross validations. I will put 10, the maximum possible, and passing or MLP or training dataset or full dataset, right? And fine, it's time to create to calculate the cross-validation accuracy. Google do this correct. This is not wrong, it's correct. But I like using NumPy for that, okay? So I imported here NumPy as NP. And I will do this using NumPy. I will print or validation, K-fold, into our scores, and the mean of it, that is based on np dot mean, and passing our scores multiplying by 100, okay? That is the percentage. Fine. Doing this, we'll have our real score. Let's do this and check how will be our model performance. He's running cross validation here. Let's wait. Oh, this one I will put to the end, because I have a good music to put when we are training into this step, guys. This one here. Wow. Execute test with real samples, right? This one will be the peak. It will be the greatest one. It will be so crazy. Okay, here we have the real score of it. We have 88% accuracy score for model, right? Really great. Interesting, right? Really interesting. So 88% of this is a good score, really good score. So now let's try seeing how Keras will do this, right? How Keras will validate and make this better or not. Probably will be the same result or something really next to this value, okay? Let's then put some new music. And then begin implementing Keras. Fine. It's really interesting because the concept of this is really next of the MP classifier, but we can create the neurons manually, right? So let's do it. This music is good as well. Let's do it in quadro. The next live stream, guys, I am thinking to reverse engineering some VM, I don't know, obfuscator malware, I don't know, I really don't know. If you have some idea what we can do in the next live stream after ending this machine learning live stream, probably I will do some reverse engineering or something else, I don't know. Really, I don't know. I'm really thinking what you guys are interested in. So, let's continue. Let's create our neural network model. Dot sequence. Fine. Oh, this is so bad. No, wait. This is a great GUI. I will stay with this. I am creating dances of each neurons for algorithm ReLU. Remember, I've told you that MP classifier also use ReLU as the linear algorithm. So the same thing is happening here, okay? The first layer, I will create a layer here, different from MP classifier that we created the layers manually, automatically, sorry. Here, with a default size, here we can classify and we can configure and create the neurons individually and with the algorithm, mathematical algorithm we prefer, right? So I have tested it a lot and thinking to the best way is to stay using ReLU for the neurons. In this case, I will create 16 neurons and the algorithm ReLU as well. And the same thing I will do is Keras, layers, dance, and then I will create 32 neurons with the same activation as ReLU, and the next one will be 64 activation as ReLU as well, ending with a sigmoid like Google create. So basically we'll have 16 neurons, 32 neurons, 64 neurons, ending with a result in one neuron that use the sigmoid algorithm, right? And then I will compile. Wait, compile? Yeah, I am compile because different from MP classifier into the TensorFlow carriers, we want to compile the training set, okay? So I will do this, but first let's put some music here for us. This is a good one. No, this one is GTA 6 trailer music. It's so bad, bro. Okay, this one is good. So, let's do this. To compile. I will compile it with the add-on. So, if you remember, we have used the solver and put add-on linear algorithm. In the same case, I will use add-on, but into Keras, we call it optimizer, okay? So our optimizer will be TensorFlow, Keras, Keras dot optimizers. Sort optimizers dot add-on. And different from this, that we can just configure add-on with no additional configuration. This one we can specify the initial rate from add-on. In this case, I prefer using some really basic influence to not influence it or performance, okay? In the loss model, I like using binary cross entropy, okay? And the metrics, how we will evaluate this model will be based on the accuracy score, okay? Fine? Okay. After compiling, it's necessary to train, okay? Here, Google show you a glue, but it's not this I'm looking for. I will create a history, and the history, I will create the fit, but before fitting it, we will pass the train and test. Sorry, the train, xtrain in itrain. Here we can configure some things. The epochs, as I said, the number of the inputs that we are gonna use, like what the fuck, bro? The number of the interactions that we'll have with your neurons here. I will do the same thing, but I will do this from 100. Fine. The batch size that we have already configured here is based on the is based on the configuration level and the performance level of our neurons. I will do using this a batch size of 32 and the validation test split, or how much of this he will use for validation. This is cool because Keras already do the validation for us, so we can configure it to like 20% of the dataset of our training dataset. And different from like underguard we have seen earlier that we have a deactivated the logger because the logger sucks, like removing the logger. This also has a verbose, but we can just configure it as 0 to not show the verbose and print out so a lot of things that we will probably never use. Okay, and fine. Now, guys, we want to predict and do the classification report of our performance of our algorithm, right? And our machine learning algorithm and neural net. For this, if you see here, we have used the sigmoid. So the last result will be a sigmoid. So then we want to convert our sigmoid to a unidimensional array, but as well creating the real score and creating the final score from our model. Let me put some music here. I will do this now. Wow, 2 hours of live. Sorry, guys. So then, I will create here the sigmoid. Fuck, I'm training. Okay, let's training. And I will create this, convert the sigmoid and everything else here, okay? It will train. This will take some time, okay? So let's wait. Okay, my mistake. I type optimizer wrong. Optimizers. Optimizer. Okay. Then I can run it. Wow, I speak his goat as well, man. Cool. Let's put some Couture is a good music remix. Fine, he has finished training. Let me drink some water, guys. It's 2 hours of live stream. Fine, I come back now. So, as I told you guys, we have a problem here that our model will predict as a sigmoid. So the last neuron of it is a sigmoid, and so the result will be a sigmoid. So then, we want to convert our sigmoid first to a unidirectional array, and then to the predict value, or real predict value. Fine. So you are wondering how we can do this. To do this is not so hard. It's really easy in the Lilith. I'll create a variable called iPredict, call the LM or neural net, predict the X test, and then predict and then I will convert or predict score to a real score. How we can do this? I will take each score here that is, oh, he got it, this is correct, that is bigger than 0.5. If it is, I will convert it as an integer, sorry, no. And I will reshape this value to a unidirectional array, okay? Why this? I am getting all the data that is 0.1. This will be true, and otherwise it will be 0 as a type of integer, okay, or only 0 or 1, not a float. And I will reshape it into a unidirectional array. This is not a unidirectional array yet. Now it will be, for I be able, guys, to do the classification report of this using the classification report from scikit-learn, okay? So this, basically I am passing the I test that we have split here on the training and the I predict that I have calculated here, okay? And then let's run and see. This is our accuracy score, okay? Let me see the message. I'm seeing the chats, okay? Sorry. Okay, so now we know that we have a 90% score. This is really good, okay, guys? Then we have applied the algorithm. We have used the classification report on our Terrace TensorFlow. Now we can do something really great and the interesting thing, that is the loss and valid accuracy. This is basically plotting a graphic that shows us in a visual way how our model is performing during the training and the fitting, okay? Sorry, during the training, only the training, not the fitting. This will help us understand if our model is a great model or not. He is like the Gen Z guy here. So then, let's do it. This way of doing this is called the plot loss method. If you read the documentation of Keras and the TensorFlow, you will see that it is really common. But they use two separated methods to do this. I have the same way to do this, but I try to put everything into one single method to print or accuracy and or another field that also is stored into a history of training, that is this history here, that is the valid accuracy score, okay? So first, let's put musics. This is a good one. So let's do this. I will create. Let's see who is mentioning. So then I will use matplotlib for this analysis, okay? Let's do it. Import matplotlib as plt. Oh, here really get it, but it's not this, okay guys? This is not the correct way to do this. I'll collect a method, a def called plot story. Not like this. I like something more interesting. So I will split this into two subplots, okay? The first one will be x1, x2, and the plt.subplots. I will take 1 and 2 and figure size is the standard. This is standard from the standard parameter as well. It's not a problem. Fuck, let this. Into x1, I will plot or history dot history, taking the loss and putting a label to it as loss. Okay? And I will do the same thing for valid loss and set the label for x epoch or iterations and for I loss. Okay? I will create a legend on it, but I like to create the legend on upper right. Okay? Here we got the second one. And first we can just set and show the grid. Okay? So grid. Grid, true, and I will do the same thing for x2, but for x2 I will plot the accuracy and the valid accuracy, okay? We have two types of accuracy here. We have accuracy of training and a valid accuracy of test. Remember, our fit training, I really do the test. We split here 20% for testing of or really training data, okay? This is the first show of it, and it is stored eating on the history. Fine? I will do now x2 and set the legend to lower right as well. And then I will show the graphs and plot the history that we have for we be able to see our real performance, okay? So first, let me see something here. This is the binary cross entropy. It's not the loss, okay? I make some mistakes, sorry. This is the POC and this is the right, okay, POC, fine. So the performance of your... Wait, I did something wrong, maybe. Let me see. Label is val loss, val loss, epoch, X label. Maybe I am splitting this in a wrong way, probably. I have this in another project of me, probably. No, this is not a good way to do as well. Valid loss, epochs, binary cross entropy. Let me think. Epoch and cross, grid as well. It's fine, it's correct. So, you can see that our loss is decreasing. This is a good indicative of that our performance is of this model is good. He's starting losing, so at the same time that during the training process, the same time that our model begin learning, he start losing and also making mistakes, right? But at some time he begins to make some raised guesses, raised prediction classification, but the loss is still decreasing, and this is so great, okay? The same thing is happening here. Our accuracy is going great, it's 90%. And your value accuracy, or the right, so the real value accuracy, the values that is really correct, is established into 8%. So this is a good indicative that our model are going well, okay? So after doing everything, we can think together. Our model has really learned, so he's not just a Gen Z guy. And we for sure have more than 8% accuracy score. So now, let's do something really interesting, really cool. Let's put some other music. No, this music is so 2015, bro. No way. Let's put another music. It's great, but it's not good for now. Oh, this is a good one. I'll put this one. Let's see the chat. Fine. So after that, it's time to execute or test with a real sample. So now it begins to become interesting. Now guys, we will train our model with real and true samples. I have separated for you guys something really interesting here. That is a repository. I have this repository here, and I want to share to you. This is the only one public that I have find it, okay? And I will use this one because oh, what? No. I will use this one, guys, because he has all the Android malware families from 2019, and I believe this will be a really cool case to try to determine if it is a malware or not based on our new model, okay? But we have some problem here, right? We have zip files, okay, including there's some Brazilian malwares here as well, okay? That is really great. Really great. So then, we have zip files, and I have seen this early. Each zip file has a password. The password is the standard that we malware analysts really know is infected. But what we want to do here is to download each file of this, extract the files, take the samples in a list, calculate the extract the features, and then run in your model, right? So then, let's do this. We are using GitHub here. This is good, right? Because with GitHub, we can just use the API, with this contents maybe, I don't know. We can use their APIs to access the GitHub and get all the context. Sorry, it's not contents. Contents. No, it's not contents. It's repo. And now it's contents. Contents. No, it's not. Bro, fuck. Okay. It's repos maybe. Yeah, it's repos. Doing this, we are able to get the real URL and the direct download file, okay? So we will do this for we be able to download and get each file from this into a new folder here. We'll create a new folder and then realizing our test, okay? So I will do this. Let's put some music to make motivation. And guys, I prefer not talking now to be fast and doing this really fast, not explain what I'm doing. Into this live stream, we be able to do everything. And in the next one, do the 2 steps that we have not done, like saving the model and creating a tool for scanning, okay? So we will do this in the next live stream, this part. But for now, let's do the test. So please listen some to home music while I code. So, wow. And the same time that the music has ended. You see this? Bro, no way, man. Fine, guys. I've implemented the algorithm here, and then now we are able to take all the paths. So let me say this is all files, samples, testing real path. There's something that we want to do now that is basic get instructor features, right? From this new samples. While this is downloading, I will code the logic for do the same thing, guys. Basically, it's the same thing that we have done on this step of parsing the features, right? But now I will put this inside our models and try to predict if it is a malware or not, okay? So I will do this now, and I will put another music for you guys. While I do this, I will try to be really fast with this, while it is also downloads, because this is the step that I really try to avoid, is because I have created a data set for you guys and everything else, really to avoid needing to downloading each sample like we have done here, okay? So let's do this. I put the music and let's program. Let me put another music, guys. I'm here. I'm just waiting what is download the files for test and also to while I program this testing case. Okay. I'll put some music for you guys. Sorry. Listen to the music and let's do it. Oh, this feels bad, right? This music feels bad nowadays. Let me say hi to Scott. So, oh, he has finished. So we download every single file from this repository for a test, guys, with all malwares for 2019. Let's get all the paths. So we got all files. And now I want to end this, guys, but have not ended yet. So please listen to this music while I wrote the code for testing it, okay? Really fast. It will not be too much longer. So it's finished, guys. Now Now let's try something here. I have wrote the code here. Ignore a hate for logger from underguard. Sorry for this. But I am calculating the error score for all malware samples from 2019. So just remember, here into this folder we have all the Android malware samples, each sample from 2029, from our attacks, from every family that have been attacking into this year, okay? To test our model, if we are capable to detect it as a malware and or not, right? So then we download each file, extract it because the password is infected. I get a list of all the paths, and now I am seeking the paths and doing the same thing we do to create our dataset. Okay, so here we have 875 samples doing the same thing. So extracting the permission things, training, and predicting. Here we already knows that it is a malware or not. But here is a complete real life case, right? So remember about the test that we have talked early. The Gen Z guy. Our model has not memorized everything. Now we have done the correct case for stud, and now it's time to test, the real test, to see if he will be able to detect the samples as a malware. I do not expect so much great performance being realistic on it, because guys, we are just using a feature, we are just using permissions. The normal way in a real scenario, the people will use a lot of heuristics, results, a static analysis results, and so on to really predict a real score, okay? To create unique features, unique patterns. But in this case, for learning, for studying how machine learning works in this type of detection malwares, this is a good study case, okay? So let me put some music, because now I will do something. Oh, I will put Hatsune Miku. I hope you guys like it. Now guys, I will calculate something called real accuracy test score, okay? Let's do it. For this, guys, we will div the length of our test samples, real samples, this, and we will subtract the error score, okay? And then we will print the real accuracy. That will be the div by the length path of this real samples, and everything multiplied by 100 to get it as a percentage as well. Doing the same thing here. Now to calculate something called the error rate, okay? We will do the same thing here by using error score by the length of our real test samples, okay? Also multiplying by 100 to get as a percentage. And to finish, we will calculate something called wrong classify, okay? Wrong classification of our model. This is done also by the error rate and also by the length of our test score, but this is not a percentage, it's to get it as this. And then there's nothing we can do. After everything ended, we just calculate the real accuracy score. So now, let's put some special music here.
I got you. It's time. And now, it's time for that moment you've been waiting for.
Let's. Oh fuck, bro! It broke in my all my vibe, you know. Okay, so we're gonna type S for list and integer. Okay, let me see where I'm subtracting something that is broken. List and integer. Len. Yeah, it's correct here. Len. Let me get this because I believe this error is here. Div manual score. Len div. The error score. Score in the length. I remove this. It's not necessary. Error rate is sufficient. Error score is not a list. It's a number. Type yes. Fuck. Where's the error, man? Put some music while I think and wait. Going back to correcting our test case. Oh fuck. Oh, bro, here. Did you see this? This is so dumb, guys. So dumb. But now it's working. No. This one. Which is the best music to hear, guys? The Hatsune Miku Counting or Happy Nation for this moment? Probably Hatsune Miku is better, right? I will put it.
Time for that moment you've been waiting for.
No, again. Fuck. No way. I hate you. Fuck. Too much. Error score. Here. Fine. Now it will go. Fine, there are more on place that I'm subtracting. This is not sense. Okay, this probably we have to force the position mathematical operators. But what is the other problem? No, it's not here. Bro, where am I calculating this? Can you guess, guys? This is the length, it's correct. The length. Bro, it's impossible that this error is here, right? It's the only way that is an error is here. This is correct. This is not a problem. Bro, what is the error, bro? Oh, now it's working, okay. Oh, did you see it's training perfectly? No, it's not training perfectly. Access 230. Oh, yeah. I have not manipulated it yet. 202, expecting 204 as input. Wait, why? Why? It is not necessary because I have the... let me see, I'll get the permissions again. Fine. Really fine. Music. That happened. Bro, 3 hours of live stream. No way, man. Yeah. This is correct now. Fine. Oh, fuck. Now run, please. Yeah, now it's running. No. Bro, again. I do this live stream, guys, so fuck, I'm so tired right now. Let me check what's over here. To truth value of an array with more than element. Want to check my arrays. Array, data set. Let me drink water. Input data and then product. Result product keras. Oh, fuck. Fuck, no. This is the fucking problem. I hate you too much, man. Now, yeah, now it's working. Now it's working perfectly. This error is because of the label. I have not put labels in my columns, okay, guys? But the fucking error is only here in the fucking result predict of keras. I hate the keras too much, but okay. Now it's working. But the problem continuing here because my accuracy score is not being calculated, and I wanted this to calculate the real score for model. Some samples are just broken, okay? I don't know why. They are not valid APK files, this is not a problem, but we can just run this and get our real score. Okay, you see, there's some moments that he really do... Wait. There's something wrong here. I will rerun. No, I will not rerun the test again. He has performed well. He is always throwing this. Why? Element 1 needs to be fit. Otherwise it will be a false positive all time. Is it 0? Yes. The two ones need to be 0. This and this. Yeah, so tired. Let me see the chat. Fine. There's something really wrong and really strange here. No. No, fuck, yeah. Bro, so dumb. So dumb. I'm not extracting the features. It cannot run without extracting the features. It cannot be real. Yeah, now it's correct. Fuck. Guys, fuck, right? Oh, I am so sleepy, guys. This is the reason that I am doing so bad. Let me answer the chat. So, okay, the unique problem here is that I'm not calculating the real accuracy score, but the model is perfectly working. And you can see here, guys, the little accuracy. Before fixing the real test accuracy score, you can see that it's working, it's classifying correctly. We have an error here, but this is just a warning because X.dot has a column names for the predict, okay? But this is not necessary, okay? We can just ignore it. Fine. With this, we want to fix this because it's necessary to calculate the real score. So this is the length of the my paths. So all my paths of my all samples that I have used in the test minus the error score to generate a DV value. And guys, this DV value, this is the problem. This is the problem that we're throwing an exception, I believe. And the accuracy score is calculating based on the div by the length of my samples by 100. The error rate will be the error score by the length of replication. It's perfect, it's working. What is wrong here? I cannot get what's happening. Why? Let it run, guys. Now we got. It will happen. Probably the problem was because I have no features and no errors values to calculate. It's running. Let's see if your model is really a real good to use in a real scenario or not. Okay, this is the real accuracy of our model. So guys, 70% of the input malwares, or this is a true malware that our model have never seen before. 7% was correct. Okay, so let's see this in a more human way numbers. Okay, I wanted to see I will now create something called wrong classifier, okay? And this is based on the error score and or all files real test sample, okay? With this, we'll really have the metric of how much samples are correct how much wrong samples were classified wrong by our model based on the length of all the samples we have on this 2019 real malwares from these families of malwares and everything else that we have collected, okay? So now, let's put the counting. No, wait.
You've been waiting for 1, 2, 3. Ready? Miku miku.
Let's let it run. There's nothing we can do. Just wait now. Fine. So guys, we just make 32 mistakes, but from 145 samples. This is a really good rate, right? So, yep, we are able to detect malwares using machine learning only with one feature in this case that we have used it, that is the oh my god, my mind. That is the permissions. Just it, okay? So, it's it. We got it. How? I have a questions in the chat. So, how did I get into artificial intelligence? Bro, I'm not from artificial intelligence. I do this as a hobby because I'm interested to see how I can apply it to detect malwares. Just for it, basically. I've studied it alone for maybe some months, and is it? I have learned a lot of things online. It's really great. Nowadays it's really easy to learn, you know? So I've taken some contents to... No, I'm not using FreeBSD. I'm using Ubuntu right now. I really like using Ubuntu. I've used the FreeBSD in the past, but nowadays I not use it more. So guys, we got 70% accuracy, real accuracy in the samples that our model have never seen before, okay? So into the next live stream, guys, I will save this model and we will create some tool for scanning or try to improve it, okay? Try to improve it, we want to take all these failed samples and input it and train again, okay? To try to make our model learn from its mistakes. But talking about these mistakes as well, we are using only one feature. This will never be so good way. Permissions are not a good way to detect malware. It's a good way to classify, yeah, maybe. But yeah, it is possible. We can do it in a certain accuracy level, like this one, 77%. I have input 874 samples to train, and with 145 samples, we got 77% accuracy score. This is great, really great. It's a real live model. We can use this without problems. The next live stream, I have planned to do this into next Saturday. I hope I can see you guys. So follow here and I see you in the next live stream. I'm really happy for you guys here watching this live stream. Thank you for it. I hope you have liked it, learning a lot. I am thinking, join the Discord server to vote to the next team for the next live stream. And this is it. Thank you guys. Really, thank you.